For generations, we've been taught a simple rule: drinking cow's milk builds strong bones and healthy bodies. It's a belief poured straight into our collective consciousness, backed by government guidelines and decades of advertising. But as dietary trends shifted in the late 20th century, fat became the enemy. Millions of people swapped out whole milk for low-fat options and non-fat yogurts, believing that skimming the fat out of the bottle left behind a purely healthy beverage. A nutritional researcher named Dr. Colin Campbell looked at this shift and came to a highly controversial conclusion. In his book, The China Study, he argued that taking the fat out of dairy is not enough to make it safe. When a manufacturer removes the fat, they actually increase the concentration of everything else that's left. By stripping out those lipids, the remaining protein becomes more concentrated by volume. And about 80% of that remaining protein is a compound called casein. Campbell claimed that isolating and concentrating this specific milk protein creates a potent promoter for chronic disease and cancer. If fat isn't the primary health risk, is the protein we've been actively concentrating actually the hazard? Now, before we look at the data, a quick disclaimer. We are exploring a highly debated area of nutritional science today, not giving medical advice. Let's look at the evidence Campbell cited. Before publishing his human studies, Campbell spent decades running laboratory experiments on rats. He exposed these animals to aflatoxin, a known carcinogen that causes liver cancer, to see exactly how different diets affected the progression of the disease. When researchers fed the rats a diet where casein made up 20% of their total calories, the animals rapidly developed cancerous liver tumors. The growth line shoots straight up. Then, researchers lowered the casein intake to exactly 5%. Almost immediately, the tumor growth stopped, and in some cases, even reversed. Campbell found he could practically turn cancer growth on and off like a light switch, simply by adjusting the dose of milk protein. To see if this applied to all protein, the team ran the same test using plant-based sources. When they fed the rats equivalent 20% doses of soy or wheat protein, the tumor growth did not accelerate. In a tightly controlled lab environment, casein functioned as an unmistakable trigger for cancer growth. The obvious question was if this biological reaction scales up to humans in the real world. To find out, Campbell co-led an extensive observational survey in the 1980s, known as the China-Cornell-Oxford Project. The researchers set out to study the lifestyle and health outcomes of people living in rural China. These rural communities provided a stark contrast to Western habits. Their traditional diets featured negligible amounts of dairy and only tiny fractions of the animal protein consumed daily by the average American. Looking at the medical records across these regions, Campbell noticed a pattern. The diseases of affluence common in the West, like heart disease or breast cancer and prostate cancer, were exceedingly rare among these rural populations. The survey data also indicated that even minor, incremental increases in the amount of animal protein a community consumed correlated directly with higher blood cholesterol levels and elevated risks for chronic conditions. For Campbell, the macro-level human data mirrored his micro-level rat experiments. He concluded that animal protein acts as a primary driver of Western disease. This conclusion clashes with the biggest argument for drinking milk. If dairy is harmful, how are we supposed to get the calcium our bodies need to prevent osteoporosis and bone fractures? Look at this biological schematic of human digestion. Campbell theorized a mechanism called metabolic acidosis. He argued that processing high intakes of animal protein makes the body's internal environment mildly acidic. To neutralize that acid and maintain equilibrium, the body is forced to find a buffering agent. It does this by extracting calcium directly from the bones. Campbell used this mechanism to explain why countries with the highest dairy consumption paradoxically suffer from the highest rates of hip fractures. He also pointed to a second mechanism. Cow's milk naturally contains hormones and stimulates growth factors in humans, like IGF-1. While these compounds help a calf grow rapidly, in a human adult they encourage rapid cellular growth, which can inadvertently accelerate existing tumor development. Combining the laboratory tests, the population data, and these biological mechanisms, Campbell reached his ultimate verdict. Humans should eliminate all animal-derived foods in favor of a whole food, plant-based diet to thrive. If this data is so severe, why do mainstream nutritionists and government agencies still widely recommend consuming dairy today? The primary critique of Campbell's work centers on the statistics derived from the China study. In short, observational correlations do not prove causation. The rural Chinese population surveyed in the 1980s lived entirely different lifestyles than modern Westerners. They engaged in grueling physical labor, consumed different total calorie profiles, and lived in distinct environments, making it nearly impossible to isolate a lack of dairy as the single reason for their good health. Critics also point to flaws in the laboratory methodology. Isolating a single, highly concentrated protein like casein and feeding it to a rodent does not accurately reflect how a human digestive system processes complex, whole dairy products. The scientific community remains fiercely divided on whether casein is a true dietary villain. But by showing how isolated milk proteins behave in a lab and comparing that to global health data, Campbell's work forced researchers to question the long-held assumption that milk is an entirely flawless health food. Thanks for exploring the science with us. To keep diving into the facts behind your food, make sure to follow Elton's Health Hacks on Facebook, TikTok, Spotify, Apple Podcasts, or YouTube.